All right. Good evening, everybody, or depending on where you are in the world, good morning, good afternoon, or good night. Welcome to the final masterclass in our series of 4 comparative cloud masterclasses led by Tim Jones with IT Masters and Charles Sturt University. This week, we're going to be focusing on modern applications and microservices. Before we get started, I will say that just let everybody know that there will be questions able to be answered about the exam at the end as well. But as usual, throughout these chats, please feel free to converse with one another. There are lots of people in the chat who are extremely knowledgeable and extremely able to, bounce ideas back and forth in the chat. If you have questions for Tim about the content of the masterclass itself, please put those in the Q&A section on Zoom. If you have questions for the operational side of things, you can put those generally in the chat section. We have Kit and Hannah once again doing admin and tech support for us. You can yes, as Kit says, set your chat to everybody. Otherwise, only the hosts and panelists will be able to see it. Yeah, you can access support from Kit and Hannah throughout the week as well at learn.itmasters.edu.au, as with the course materials, the previous recordings of webinars, and any other information that you are looking for about the webinars in the short course series. As well as a little reminder just at the beginning as well that there will be a survey about your experience with this course. And that's going to be accessible as well via learn.itmasters.edu.au. Please do get in touch with us about the survey as well if you can't find it or anything. But yeah, please fill out that survey. It's very helpful for us to improve the short courses and to improve the IT Masters kind of experience. Yeah, we'll have a little bit of a chat about the exam and things towards the end as well. And in the meantime, thank you very much everyone for attending. And here is Tim Jones.
Thank you very much. Now, just to before I begin on that, there's been a couple of notes around the slides that are on the website, the week 3 slides. So my apologies, that's my error. So I've sent through to the team a file that was marked as week 4, but didn't actually have the week 4 content in it. So after this, I'll make sure that we get the right content onto the website. So once again, apologies. The correct information will be going up after this, and so you'll have a copy of it later on tonight or tomorrow morning. All right, so to get into the start. So first of all, we're into week 4, obviously. We're working through these topics tonight. Now, one of the questions that's come up immediately is what is the cutoff for the labs? So anyone who's signed up, going with them, you have until the end of July for the lab environment. Anyone that's looking at this from a recorded sense, you have up until the end of July to sign up with us for the course and to then get access to the lab environment. But the lab environment will close down at the end of July. So you have several months from now if you're live, and from whenever you're coming in later, you have up until the end of July. And if you come in after that, because you're coming into the recorded sessions, you won't have access to the lab environment. But it's the type of environment you would have if you join one of our master's courses or one of our other courses that are available. Okay, so going through here. So we're looking first of all at architecture in the cloud. The idea behind tonight is to pull together a bunch of the things that we've learned over the last 3 weeks and coming into the 4th, and bring it together for what it actually means for deploying applications, making change, and enacting new systems and capabilities in an enterprise style workspace. So what we have with this is a whole bunch of information that's been written by many people around what it means to architect solutions in the cloud. So once the correct file goes up onto the website, you'll have the links to read all of these at your leisure. But what I thought would be good to go through at the moment is just a brief view of what each of these different types of architectural frameworks or views of how we deploy applications in the cloud looks like. So first of all, from the AWS perspective, we have the design principles. And so what this means is this is how they suggest that you deploy your cloud-based applications and cloud-based infrastructure based upon how they have as best practices for deploying those types of systems. So part of that is from all of these systems is, first of all, to perform operations as code, which is what you'll see commonly across the board from cloud providers, but also infrastructure as code and modern DevOps or DevSecOps type capability for deploying into your own data center. So one of the big advantages that you have from deploying as code is that every time you deploy something which utilizes digital assets, which is our scripts or our configuration files, our Helm charts, or any other components that we have to deploy systems, it means that it's the same every time. It doesn't matter what systems it's on or anything like that, it'll deploy in the same sort of manner. Rather than the normal way that we deal with monolithic applications of making massive changes at really infrequent intervals and having huge testing cycles, the view is to make frequent, small, reversible changes in cloud environments. To refine your operations procedures on a frequent basis. So the capability of this is that we change as our applications change and our systems requirements alter as well. Anticipate failure. So this is not only from the perspective of architecture and designing the systems, of making sure that we anticipate these sort of things, but to do a often paper-based exercise or a whiteboard exercise with a bunch of experts to do a pre-mortem. So this is something that I've been involved in a couple of times. There's a whole bunch of people that are really keen to do post-mortems, to have what can be in some situations a finger-pointing exercise to work out who's to blame for something failing. But pre-mortem exercises has everyone go through where something could potentially fail and working out on paper whether that type of situation will cause a major outage. And if it will, how can you go through and mitigate for that, or if you do need to? And learn from operational failures. Right? So every time we have something go wrong, whether it's security, identity and access management, whether it's a failure of scripting or something else. Right? So we want to change that and tie that back into refining the changes again. So learning from our mistakes and iterating on these sort of capabilities in a very regular sort of view. And all of these sort of ways of implementing cloud-based applications tie back to the way that many people might now see project management and project implementation work with agile methodology. So running epics and sprints and different ways of deploying new capability into organizations in a much more rapid manner. So that's the AWS view. We've got something similar from Azure. Right? So here we're again designing something that's robust. We've got redundancy, we've got self-healing, but also importantly, we're calling out that we want to be able to scale out our application. Remember, there's two different ways of scaling our systems. We can scale up, which means that we add additional processors, additional RAM, And this is the old school way of dealing with application requirements. So looking at a mainframe, for example, we would deploy the system and upgrade all of the components in one massive piece of iron to make the application run faster. When we're architecting cloud-based solutions, as much as possible, they should be designed so that they can scale out rather than scale up. We want to partition around limits. Right? So what this means is if we do have limitations, we want to make sure that any workloads that come into that space are not going to overload the environment that has limitations. Design for operations, use managed services, and use the best data store for the job. All good suggestions. But one that I really like is design for evolution. So tying back again to what we were looking back at with AWS of learning from our mistakes, but having a very clear view that our systems aren't static. We can build potentially the perfect architecture of cloud systems for right now for our environment. But the user base changes, the application type changes, the capabilities of the environments change. And so we need to keep an eye on what that means to deploying applications over time. And finally, we want to build for the needs of business. So this is one of the really core things. We'll go into some things around regular business and application architecture a little later. But at the core, our role is not to deploy technology. Our role is to meet business needs that derive some value out of the technology that we deploy. So the technology is all there to meet some requirement. So understanding what that is a really key part of technical work at any level, whether it's an architect such as myself, a project manager, a cloud administrator, or some other role within the environment. Understanding what the business is looking to get out of the system gives us a perspective of what's required to deliver and making sure that that's kept in mind for all of the components that we're making. From the Google perspective, right, so they've cut it down to 5. So we started off with the AWS principles. We've got the list of 10 from Microsoft, and we've got the Google ones as well. So to start with, we've got automation again that we're looking at. So we want to, again, automate things with digital assets. We want to be smart with state. So this is a different one from what we've had in the others. So this is looking at cloud native applications, especially when we're looking at web scale. And when we're talking about web scale, we're talking about applications such as Instagram or Facebook or something that's designed to be able to scale up very rapidly. Now, if every time someone accesses the application, it expects that you're coming to exactly the same server because each server has a particular user list on there or capability or local store or something like that, that's what we call state. Right? And the ideal is for as much as possible to move state elsewhere. Such as last week, we looked at NoSQL databases and putting state into a NoSQL database or into, some people might have heard of Redis or some other type of in-memory cache capability is the perfect sort of place to push that off to rather than have your web servers actually store information. Because one of the things that we want as part of that is for things like web servers to be ephemeral. We don't want people to have to connect to the same web server each time. We want to favor managed services. So what this means is at the back end, we don't want a whole heap of people working on every little nugget of technology and capability. As much as possible, we want to push off as many tasks into the cloud service provider because they do it really well. The services are there and allows us to avoid a whole heap of work that we otherwise wouldn't need to. Now, existing applications might make that difficult, but this allows us to, especially for new applications, to focus much more again, on what the business needs and delivering technology for those business needs rather than technology to support the technology to support the technology to support the business needs. Practice defense in depth. Right? So security is incredibly important, whether you're deploying an application internally or deploying it to 5 million people around the world. So this is where you might have heard me talk about DevOps. Right? So this is where we have cloud administrators and cloud engineers and that sort of thing. One of the things that's come slightly after that is what's termed as DevSecOps. Right? So this is the operation of using cloud-like technology, infrastructure as code, of deploying using automation. But every time you're managing one of those automations or capabilities to deploy applications and systems, at the very core of what everyone is doing is a view towards security. So I mentioned before that everyone having an understanding of what the business requirements are, of what the end goal of the business of the application set is important. But having a view of making sure that each and every one of your components has a level of security that's suitable for the task at hand is important too. So when we're talking about DevSecOps, it's everyone having that sort of view with their task, whether you're a developer, whether you're an architect, or whether you're a cloud administrator. And similar to what we had with Microsoft, always be architected, right? So change is continual, it's not going to stop, right? So if you're someone who wants to learn something once and then keep doing the same thing for 40 years, then maybe look at being an accountant or something like that. Moving into the technology space, you need to keep abreast of new technologies, new capabilities, and you need to understand how to implement them, but importantly, be able to view what is important in the sense of our cloud architectures and things we're looking to deploy, of what needs to be updated soon or in the next cycle, something like that. We got another one from Google, their cloud architecture framework. I won't go through that. That copies a bunch of the same sort of concepts that we've just been through. We've also got this one. Let's see. We've got here the MuleSoft moving to the cloud. Now, the reason why I've got this here, MuleSoft is a major API application-based company. So the software and capabilities that they deliver help us develop microservices and stitching existing applications together into a whole. So they help us deliver microservices, application capabilities, and integration with existing or legacy type systems. Now, they go through a great deal of information in here, suggesting how you go through and approach it from an application standpoint. A lot of what we've looked at so far is looking at the infrastructure nuts and bolts, but looking at the MuleSoft piece as a major vendor and capability is something which takes a different sort of view from the developer standpoint rather than the infrastructure view. Now, just as a side, so MuleSoft is also now owned by Salesforce, who are probably the biggest software as a service platform, which is in most organizations as well. So that's an environment that needs to be integrated with on a regular basis, and managing how data is managed and integration between different applications is super important there as well. And the last one here of what I'm referencing, we have a look at the view from HashiCorp. So some of you may have heard of HashiCorp before. The main products that I've had touch points with are Terraform and Console from them, but they have a bunch of technology, the suite of applications for assisting with deploying cloud native or modern applications, and the ability to have scale out systems, infrastructure as code, continuous integration and continuous deployment. So this is a good view of not only how you deploy applications in the cloud, but managing the links between existing data centers in the cloud, etc. So my experience, there's a bunch of smaller companies that will have been able to go directly to the cloud. They'll be able to exit their data center and go and have all of their applications sitting in the cloud. But any of the clients that I deal with, they've all still got data centers of some degree, but they're also in multiple hyperscalers as well. So multiple cloud environments. Just about everyone is in at least 2 of AWS, Azure, and GCP, and many of them have other cloud environments and software as a service and other capabilities that are around. So the idea of how you manage that cross-cloud space and pulling information from multiple disparate sources and managing application architectures that might require pulling data from different cloud environments requires an understanding of what's happening under the hood from an infrastructure level, but also having a concept of how you can stitch those applications together using higher level protocols. So that's one of the things that HashiCorp and their components are really good at as well. All right, so I've spoken about that a fair bit. So one of the other components that I think is important about this, you heard me talk about multiple clouds being the norm for large scale organizations. So large enterprises have multiple clouds. They've often got multiple data centers, and they may have multiple systems in co-locations as well, edge locations, all over the place, as well as software as a service platforms. So one of the concepts which is becoming a new view of how you deploy applications is data-centric architecture. And what this means is that rather than deploying each application and then working out how to link them together, you work out what the data is within your organization, how it needs to interoperate, and putting some design principles around how you deploy that data or make it available. So as an example, I've got a colleague that's gone to work at a company called DataStax, and they provide a Cassandra database. So that's a NoSQL database, the same sort of database that that all of the main NoSQL databases from the major providers is based upon. And you can deploy that in any of the clouds or in a co-location space, which has high-speed access to all of the clouds. There's also from Dell Technologies, it's a company that I work for, there's a product called Factor, which is a large-scale unstructured data repository, again, in a high-speed cloud environment with high-speed connectivity to all of the public hyperscalers so that you can have a shared repository across multiple clouds. Different models for how you deploy or work out your data-centric architecture. In some cases, being data-centric might be more of a logical view of how you manage your data assets and the links between them. But it's certainly something to keep in mind of how applications will gain access not only to the data within their own application set, but the links that they need to outside systems, the delays or latency that might be involved with that type of link, and the long-term management of that data over time, especially when multiple applications require it. So before I launch into the next section, I'll just jump over to the questions. All right, so questions are reasonably light so far. So we've got a question from Leo. Tim, with reference of designing a system to meet business needs, what control measure can be used to maintain this aim? All right, so bear with me. I'll go through something around that in just a second. So I can't remember whether it's this section or the next, but I'll go through that shortly of how we deal with the business needs and business requirements. Hi Tim, can we have a copy of the HashiCorp white paper, please? Absolutely. So that's linked in the PowerPoint slides. So once I hand through the correct version of the PowerPoint slides, you'll have access to that. So bear with me.
Thank you very much, Tim. And I will just answer a couple of questions that I've seen in the chat regarding the exam. Just a reminder that we will be discussing the exam in a little bit more detail towards the end of the webinar. But for the moment, just a couple of sort of FAQs. If you haven't received your invite to the AWS Cloud Lab environment, they're sent out weekly on Tuesdays. So they are being sent in waves. So some people may not have received them yet. If you haven't yet received it, it may be sent next Tuesday. Otherwise, please check your junk or spam or promotion folders in your email. And if you still can't locate your invitation, please send us an email at shortcourses@itmasters.edu.au. And yes, so the exam will be up towards the end of this week, and we'll give you a little bit more detail towards the end of the webinar. Thanks.
Cool. Thanks very much, Jack. And you see in the questions answer, we've got a link to the HashiCorp Cloud Operating Model. So it's a good document, lots of interesting information. Another question from Leo: what is the most common use of cloud applications, i.e. data-centric or other? So what we continue to see overall is the deployment of systems is application-centric rather than data-centric. There's links between applications, whether it's using data loads into a data warehouse or into a data lake, but it's not using live data, and it's not having a data architecture which is spanning the organization. So each application often still looks like an island. So one of the things which I've worked on a project with a company that you may have heard of called Splunk. They do a great deal of work, especially with things like syslogs, of security logs from multiple systems for security analysis or other analysis of things that are occurring across the network. One of the use cases they have with their platform as well, because you can feed it any type of information that you have available, is you can tie it in live to your application systems and use that to knit together your applications to be systems of experience for the end users. And so that there's the capability to do live querying of systems rather than waiting for data loads, which might be daily or weekly or something like that. And what that means is that there's the possibility to have the democratization of data across an enterprise as well with a data-centric model or a data architecture which allows full access to what your organization is doing at any point in time. The example that I use in that is a company like NBN that might need to do truck rollouts on a regular basis. And there's a great deal of data from data warehouses that are available to managers that want to run reports to see what's happening with truck rollouts, with weather, inclement weather that might affect things, or failures that happen across the network. Now, that's all well and good for senior managers to have that sort of information, but Imagine, if you can, if a end user that works in one of the trucks that knows exactly what it is they do on a day-to-day basis and how they did it, is able to query business-wide information around questions that they might have pertinent to their own personal job, the insights that they might be able to glean, and the information that could then be used to enact change in the organization, because frontline people who understand what they're doing on a day-to-day level at the best, in the best sort of sense, are able to get access to data that would normally be completely alien to them. Right. So question from Bruce. Data-centric sounds idealistic, particularly on interfacing between apps use cases. There's some good examples, you know, if we could look into. So this really does come into the view of how you're looking to deploy your enterprise architecture across your network. So yes, it's idealistic from the perspective of individual application, but it's an important question of how you manage data from an application to application perspective. Again, the democratization of data that you might have within the enterprise, but also on how you manage that data set in the long term. Right? So having things like expiry of data, of having save times to make sure that you're meeting compliance requirements, but having that sort of capability at an enterprise level. And we're starting to see with some of the technologies that are coming out, some of the new models and frameworks that are available, but the capability of doing that sort of thing is sort of coming to light now. So cloud applications are still monolithic, not necessarily. So just because an application is it's application-centric data doesn't mean that it's monolithic as well. So the two aren't synonymous. You can have a monolithic application which lends itself to being data-centric because of the way that the back-end data systems are dealt with, or the way that the interfaces are made available or capable of dealing with other things. In a similar manner, a microservices application isn't necessarily data-centric, and often they're not. So in the most case, we see applications are deployed to meet an individual business need, and after they're implemented, the data they have inside them is found to be valuable, and there's links that are then required between applications to deliver it, rather than having a data architecture which the new application is adding to. And final one from Leo. So data-centric applications are more for data science functions. Not just data science functions. It enables data science functions and can permit you to have, as the example I gave before, live access to what's happening in your organization right at this very moment. But it can also just be around the maintenance of data, of the ease of integration between applications or other functions. So it's not just for data science. Okay, so now looking at bringing together the components. All right, so this is where there's a question from Leo before around requirements. So a bunch of people might see this as something familiar. A bunch of people might be scared of it if they know what it is. So this is the TOGAF ADM. So this is the architecture model for how you deliver an architecture using the TOGAF framework. Right? And whilst we're looking to deploy modern cloud-based applications, this sort of iterative approach for how we deploy architectures and manage the architecture delivery process is still pertinent to what we're looking to deliver into the cloud. Right? It's a rigorous process. You don't need to use all of these. The individual components, you use the things which make sense for your business. You can take bits and pieces out of the TOGAF framework or use a completely different framework. But the ideal of TOGAF is to provide a common sense view for how you deploy an architecture. Right, so in this, you end up with a preliminary view of what it is that you need to do from the business, etc. The architect gets involved from having an initial brief, has an idea around what things may look like, and they then run through the architectural process. Now, you'll notice in the middle, we've got requirements management is part of every step of the way. So that ties back to the initial business problem that is put in front of us, and that the requirements are based upon what the business has said that they need. So keeping that in mind and continuing to check at each stage that we're both meeting the existing requirements that are in place, but making sure that the requirements themselves are still pertinent. So I've worked on some projects that have taken many years. I remember one project that I worked on in 1999 to really age myself. And someone said that project was actually delivered in 2016 finally. The final iteration of the project was done in 2016. It had already been working for like 6 years before I got involved in 1999. All right, so it's important, especially when you're dealing with long-running projects, to keep checking back to make sure the requirements are still true. It's no point continuing to develop some capability if you're developing to a requirement which the business no longer needs. Right? You're wasting time and effort, and you're not actually doing anything that the business actually needs at that point. Right? So understanding these sort of things is, as I say, TOGAF is kind of old school, pretty uncool, but it's still a very valuable framework for mapping out what is a good thing, a good common sense thing to do at each step of the way of how you deploy your architecture for your organization. So as an aside, this is a view. So this is from my global team within Dell that have developed this. This is quite an eye chart. What this is looking at is all of the individual components that go into deploying a multi-cloud capability for your organization. Right? And what this means is, what individual components or application pieces would you expect to see? Some of these things are combined or not required for our organization. But starting from the top down, if we're looking to deploy a multi-cloud deployment of applications, and when I'm saying multi-cloud, I don't just mean multi-cloud as in multiple clouds, but multi-cloud as a noun in itself that is a way of deploying applications using infrastructure as code and those sort of DevOps modern capabilities. Right. So for that, we need things like federated role and user capability. We need cross-cloud capability and other functions that need to sit under there based upon what our requirements are. Right down the bottom, we've also got a whole bunch of infrastructure that at its base supports that. So within any of the cloud service providers, you would see a selection of these things as well. So we would have software-defined hypervisors, we'd have compute network storage, we have software-defined infrastructure, we've got insight, reporting, monitoring, other capabilities across the board. All right, so when we're planning an infrastructure view of how we're looking to deploy something across a large-scale enterprise, we want to have an understanding of how we're deploying or managing some of these functionalities. Right? So as I said, you don't need all of these, but you at least want to have an understanding of, from an enterprise architecture view, looking at your service capability within your organization. You want to be able to go through each of these and say, well, I need it or I don't need it. And if I do need it, is it something that we've got? Is it something that we do well? Is it something that we should be changing? Again, coming back to those precepts that we were looking at earlier, if we need to, we should re-architect, we should change, we should get operational feedback and feed that back into what we're doing. And when we're talking about those feedback models, again, that comes back to what we're looking at with the TOGAF model of working out our architecture, deploying, but this is a continual cycle, right? So this is reiterating what we heard from AWS, from Azure, from Google, that we need to keep architecting the whole time. It's not something where we're one and done. We don't create the perfect application and then we deploy it and everyone steps away and says, well, that's great now. Right? So you need to keep on top of these things. All right, so just have a look through here, Jack, around the questions.
Yeah, so we've got a few about TOGAF. So if we want to start with David asking, how do you do TOGAF in an agile world?
Yeah, so you have a look at the TOGAF information. So this is a pretty basic view of how you run a project from an architecture perspective, of creating an architecture. It looks kind of old school from an agile perspective, from a modern application perspective. But the process of creating an architecture by its very nature needs to in some way be a cyclical approach, right? So we can't follow normal direct agile capability for deploying an actual architecture itself. This is the documentation side of an architecture I'm talking about, of the work that an architect does in the prelim to developing an application set. So you can't fail quickly, right? So one of the really big things that you can do with architecture is spend more time up front, making sure that you understand all of the components, that you have as much feedback both internally, but also from external parties such as vendors, from service providers, from other parties along the board. And getting all of that feedback and feeding that into your architectures is incredibly valuable. And spending the extra time up front, right, of not failing fast, which is a common ideal of agile or quickly deploying applications capabilities in a sprint, is that any time that we spend upfront saves a lot of time for all of the people that will be working off that platform. So it still maintains a iteration. We still feed back into it, but there's a level of pre-work that needs to be done outside of the normal agile space. But the actual implementation of the architecture and the work that the architect then does with the sprint teams, the epic teams within an agile methodology, it very much works within that framework as well. So there is reasonable crossover, but TOGAF is separate from the actual TOGAF process, from the agile process itself. So question from Leo, does the TOGAF framework have lower level components reaching different operational teams to make the architecture succinct with the design? All right, so this is one of the things that we work on when we're creating our architecture. So first of all, we make sure that we socialize the architectures with the teams that will be responsible for delivering the work. That people have an opportunity to understand it, to provide feedback, importantly, not only because they'll be the people that are deploying the application and that they'll be the ones doing the actual work, but also because they are absolutely subject matter experts for the end of the line work that needs to be done, whether they're individual cloud engineers or any other type of specialist capability. They understand what happens right where the rubber hits the road. So there's only so far that you can go as an architect. So I've been an architect for many, many years, and I know a huge range of technologies, right? I've worked on mainframes, I've worked on AS400, I've worked on mid-range systems, Linux, Windows, whole range of database technologies. I've worked with cloud service providers and everything. Right? And so I know a massive range of things, but I know it that deep. Right? So I don't have the experience of implementing technology in anger for a very long time. Right? So no one wants to put me in front of an actual keyboard to do any real production workloads. It'll be a very dangerous thing. But the people who do that understand more the ramifications. They deal with the change management process, and their feedback is incredibly important. So the process of dealing with all of that ties in with how you deploy the architecture, but again, comes back with how you work with those teams longer term. A question from Stephen. Quite a few circles in architecture slide look like non-functional requirements, e.g. tech architecture. All right, so technical architecture is still important. So we work backwards. First of all, we work out what it is that what the business problems are. We work out the business architecture, what the process looks like. We then look at the information systems architecture. So that's looking at the data architecture and the application architecture from a TOGAF perspective. And once we understand what the data architecture and application architecture looks like, the technology architecture flows out of that. So each step of the way, remember, we're coming back to the requirements management. So those non-functional requirements for how we deploy our technology, that will fall out of the process of the business architecture, then the application architecture and the data architecture that we deploy as part of the process will define and help us find what our technical architecture actually looks like and give us those non-functional requirements that help us map the systems or capabilities to what the upper level systems that we're looking at need to be deployed. And a question from Nazmul, how to deploy TOGAF? So TOGAF isn't something you deploy. It's purely a framework, a way of a methodology for deploying architectures and dealing with creating architectural teams and capabilities within organizations. So it's more of a people and process rather than a technology discipline. All right. So looking at building microservices. So first of all, looking at microservices, they first of all can be deployed independently, right, and allow for team autonomy. And what this means is that we can have standalone microservices that are built completely by a team. The interfaces are well known and any application can gain access to it. So an individual microservice can be completely standalone. So you're going to have a web-based API that is a single microservice that is utilized by multiple people across the web. Right? So that's a completely standard and accepted pattern for deploying microservices as an individual component. Now, what we're talking about when we say team autonomy is we can have different teams that are responsible for different parts of the technology. We can have one team that develops in Node.js because they're in Belgium and that's what they develop with in that team in Belgium. We can have another component of the application, another microservice, which is developed out of Singapore. And in Singapore, they use Python to deliver the capability because of the data references that they need and the framework that they need to help deliver that. So with that, they can have different capabilities within there. But because we've got a much smaller component, that brings us to the second point. Right? So each of these are independently scalable. Right? So we don't require, when we scale one component because it's getting a lot of traffic, we don't need to scale other components. But the other side of it is we do expect that each of the components are scalable. Right? So the architecture and design of each of our microservices should be designed with scalability in mind. Now, in some cases, it might be that one of our microservices, our components that we're using is a data repository and it needs to be running on a single machine. We've got backups or something like that. And for that component, we might need it to be vertically scalable rather than horizontally scalable. That's fine. We can deal with that, but it really depends upon what our requirements are for the application as a whole. We want to reduce downtime through fault isolation. Right? So with this, using microservices, we expect that the time to find any particular fault will be much quicker because we're not running, we don't have components running in a complete black box. We can independently test data against individual microservices or view where it is that particular microservices are failing, either where they're requesting information or passing information back. We have a smaller code base, so it's easier to understand and maintain. Right? So again, we've got a single microservices capability, so we'll have a much smaller amount of code that needs to be gone through. And the expectation there as well is because you've got a team that's dealing with a small code base, the team that's working on it on a day-to-day basis understand it really well, but also it should be well maintained and documented what each of the components do. And finally, our microservices also fit well into the modern application delivery frameworks. So things like CI/CD, so it's continuous integration and continuous deployment, where you automate the process of enacting change in your environment. So you no longer have a change window that's on a Wednesday night at 10 p.m. or something like that, where changes are actually made into your production environment. The expectation is because each of the microservices are atomic, they're scalable, you can add individual components to the network, including updated versions of the capability, make sure that it actually works, and then build up to a full deployment of the application. So what about concerns? What concerns people about deploying microservices, of dealing with them on a day-to-day basis? So one of the big things is it's a very different type of complexity than monolithic apps. Right? So when we're dealing with a monolithic app like SAP or SAP, we know what it's going to do at certain points. We know what the failure points are, or that we just need to throw heaps and heaps of hardware at the database for running SAP HANA or something like that. We also have a wealth of people that understand the application quite deeply. So for enacting change in that sort of environment, there's a whole industry of people who are able to assist with that type of monolithic application. With microservices, when we're building up these custom application sets, we have much more constrained capability to know how each of the individual components are working. We could, again, have parts that are written in Node.js, some that are in Java, some that are in Python, right? And so understanding the full application set can be difficult. And this is where having a well-detailed application architecture and enterprise architecture for the organization is really important. The other thing is the interface control is imperative, right? So if you don't have full control of the interfaces, this is the APIs, the way that the microservices communicate with each other or with the external world. If you don't have complete understanding of what that's doing from a higher level, then the application can break in very nasty ways. Because if you have individual groups that are making ad hoc changes to the way that the interfaces work, then other parts of the application will stop working. And the other thing is that it could cost more upfront, right? Depending upon what your monolithic applications or anything else looks like, going through and deploying microservices, whether on Kubernetes or function as a service or virtual machines or utilizing software as a service components or any of those sort of things, it could be more expensive, especially if you've got a sunk cost in an existing data center of a bunch of servers. You've got the cost of migration to microservices, but the actual running on a day-to-day basis could be more as well. It could be less, and depending upon if you're building or architecting for it to cost less from an infrastructure perspective, then you can probably most likely do so. But it's something that that depending upon what models you use to deploy it, it's something that could come back and hit you if you were expecting to get a financial benefit immediately out of moving to microservices. So how do we build? All right, so building, we want to have a clear understanding, first of all, of the business drivers, requirements. Again, coming back to what we were talking about with TOGAF. We want to have articulation of the architectural vision and planning. Again, coming back to that model that I was talking about before of spending as much time as possible upfront and not rushing into the deployment of the applications. There's any time that you save by finding problems in the planning phase when everything's on paper, you'll save 10 times as much than what it would mean if you found it when people actually started deploying the application itself. So interface points clearly mapped before any development. Again, this comes back to adequate understanding of what the application is, how it'll operate, and making sure that those interfaces are mapped as part of the documentation, architecture, design, anything else that needs to be done before starting the application work. We have multiple dev teams, again, often working in agile project methodology. This is just because the working in that type of team lends itself to very quick iteration cycles, small teams delivering new capability very quickly. And we want to have thorough and, if possible, automated testing of all components as part of our microservices build. So this again comes back to continuous integration and continuous deployment, that if we can finish developing something at midday and that we've done our unit testing. So unit testing is where developers test on their own machines to make sure something is working. The code could be committed at midday and we could have automated tests run for the next 15 minutes and we could have it deployed into production at 12:30. So what technology do we build microservices on? Right. So again, the technology should not come first. We shouldn't be building and have an idea before we start deploying an application what the technology looks like. We want to have a very clear understanding of what those requirements are again, of what the business needs are, what the application and data architecture looks like to make sure that anything that we're deploying or planning meets those requirements, and we should have all of those completed first. So, but we can build it on VMs, containers, serverless, or SaaS. So there's multiple ways that we can we can deal this, or a combination of all four of those. There's no limitations to what microservices need to be. Just because it's a modern word doesn't mean that we can't run it on virtual machines or cloud virtual machines or anything like that. So that can be quite an acceptable pattern for deploying our application. Again, it comes down to what our requirements are for running the system. All right, so before we move into migrating to the cloud, we've got a few more questions.
That we do. Would you like to answer this question about which cloud-based platform is most relevant to a data scientist?
Yeah. So from a data scientist perspective, the cloud platform that has the most weight with data scientists, and purely from a data management perspective, Google Cloud seems to have carved out a niche in that arena. Not to say that you can't do similar capabilities with other platforms, but the way that you operate and gain access to Google Cloud and some of the tools and big data sets that you can operate in there lend themselves to the way that data scientists like to work. So it's more of a people and process type capability as much as it is the technology or costing or anything like that. So what else have we got here? So that's the question from Innocent. We've got one from Marley. So what is the best tool to implement CI/CD? So there's no best tool. Again, this comes back, we don't want to start with a view of the technology we're going to deploy because we want to deploy continuous integration and continuous deployment. We should decide that, first of all, our business needs continuous integration and continuous deployment because they have a need for rapid deployment of new capability from a market perspective, or because of a bug fix capability or something else. So if the business actually requires that new capability, then we should first of all look at integrating those sort of capabilities into our application deployment process. Now, if we've decided to do that, we can again go back to the architecture of how we're looking to deploy this. We're pulling in all of the requirements. We're building out the broader architecture. And it's only when we understand how we're going to use it, how developers operate in the environment, what technology they use on a day-to-day basis, that we can map that back as to what continuous integration and continuous deployment looks like. But having said that, from the perspective of deploying applications and the capabilities, the common sort of things for doing that are applications such as Jenkins, which provides some of the capability, some automated testing and automatic load of new containers or other application sets. You have repositories such as GitHub, which is very common again and available to everyone to utilize as a code repository space that again ties in with that. And we've got products such as HashiCorp's Console, which can assist when we're actually deploying applications, of making sure that they're registered with DNS or that our other applications can find them. So there's a range of systems and a range of capabilities. So those three examples that I gave are part of what we play with in the lab environment for the microservices and virtualization course that I run, that'll be running later this year, as an example. A question from Leo. Are there any methods which can provide conversion of legacy applications to microservices types of systems? Yes, yeah. So one of the key ones is the ability to migrate or convert applications into containers. So if you have a small application base, you can deploy that application as a container and then potentially have it easily deployed as a scale set, as an example. And so, but that is really very dependent upon what you're doing. If you've got a custom monolithic application, you really need to have a keen understanding of what's happening within each of the components. Now, to convert some applications across, it can make sense to take piecemeal approach of individual components and what I'd term as evaporating the application. The pieces that are easy to move into microservices, whether it's function as a service or serverless, or taking components and moving them into containers, you're taking part of the application across and making it available in a modern setting that's able to scale out and be managed in a much more easy manner, and that you can go through and continue to update in a microservices type framework. You might be left with a whole bunch of stuff which is like spaghetti code, right? So a bunch of systems that make internal systems calls using not well-known APIs or hard-coded IP addresses or something else. There's a whole bunch of messy ways that application developers and infrastructure people deploy applications into production environments that makes it incredibly difficult to enact any change in the future. And so for those components of a monolithic application, when you've evaporated the application as much as possible, taken out the easier components that can still talk with parts of the application, but you're managing them separately, you may need to redevelop or refactor the application for the rest of it. Question from Anonymous. You're saying that we need to have a viability business case done prior. So the viability of the business case should be done by the business. So before it even comes to an architect or anything like that, there should be a valid business case for why it is that we're deploying any new technology. The expectation is that there's a return on investment in some way for making change within the organization, other than things like maintenance and security and those sort of things. So the expectation is that anything that we're doing with technology should have some value, right? And that should be measurable. So the expectation is that if the business is putting forwards $5 million to deploy a new application, they should be able to show their business management that the application set is going to deliver $10 million or something like that. Is a normal sort of view of how these applications get up in large scale enterprises. Now, the opposite of that though is that within large scale enterprises, there isn't very often at all a process for going back and checking that applications have actually met their return on investment. Right, so the business people are able to go through and give whatever figures they want for a return on investment, and often that doesn't come true. Often you have applications which sit there after spending tens of millions of dollars that are largely unused or are bringing very little value to the organization. So it's so yes, they need to do a business case, but it doesn't always pan through that it's as worthwhile as it could be. Question from Stephen. Clear understanding of business drivers' requirements sounds more like waterfall than agile. Yes, and that's where I was saying that the architecture and the upfront methodology is not in the process of failing fast. You want to spend as much time as possible iterating through the architecture and the design process and understanding what the requirements are, working with business analysts, business people, with other experts, etc., and making sure that you get the design and architecture correct before anyone starts doing any actual development work. So it's a different process than what we would expect having sprints to deliver individual components. We can certainly use some methods of agile methodology and architecture of having sprints for sections or portions or whatever, but it becomes a little bit more nebulous. But also, again, you want to, if you need to, spend more time on making sure that you get the architecture and design right before you do any work whatsoever, even if it's not going to hit a timeline or something, because the amount of savings that you will get from spending an extra week in design and architecture can save months in development and deployment. Can we say virtual machine migration is a component of microservices provisioning? So, as I said, the virtual machines can absolutely be part of a microservices deployment. But again, what we expect to see with microservices is that they are atomic and scalable in and of themselves. And so we expect them, so if you've got a virtual machine that can be cloned and you can make as many copies of it as you like to sit behind a load balancer, and that if one of them disappears or a whole bunch of them disappear, then that's a virtual machine microservice. It doesn't need to be a container or a function or anything like that. But it does, for it to be termed microservice, it needs to be independently scalable, and we need to be able to preferably scale out the environment, and with the expectation is that it's got a relatively small code base for the application that's sitting on that virtual machine, and it needs to be ephemeral, so that if we lose one of the systems, that we're not losing anything majorly. All right. From Anonymous, is there a deadline for taking the WS Cloud Foundation modules? So just the end of July. Can we, from Nazmol, can we, in greeting GWS, GCP, or Azure in the same, integrating the three cloud platforms in the same platform using VMware? So yes. So there's VMC on AWS. So this is the capability to link between your on-premise VMware environment to AWS, and you've got the capability to do the same to GCP and Azure. Slightly different methodologies, but you can link to all three. You can't have AWS, GCP, and Azure VMware environments talking to each other, but they can all talk back to a central data center with VMware. Okay, so now just moving on to migrating to the cloud. All right, so to start with, this is something that's that I've got a chat with a CIO next week of a big company, and this is putting things in a method that a CIO can understand. And so, talking dollar signs, resources, and not getting too technical. Right? So, this is what this is showing is basically what a migration to cloud services or cloud capability looks like for an organization. So any organization that's mainly using applications in their own data center at the moment, they have multiple different capabilities. They've got data center operations, server admins, network admins, storage admins, DBAs, and a bunch of other specialist tasks within the infrastructure space. And at the moment, they have a bunch of people in each task, and they might have a small cloud presence where they've got some cloud admins that are looking to manage that sort of capability. Now, in a phased approach, we say over time we start to deploy cloud technologies more heavily within the organization, either through using internal hybrid clouds within your own data center, or more commonly moving to one of the hyperscalers. And so through a phased approach, we see what happens is when we deploy applications in the cloud, rather than having people manage each of those individual components, we now have cloud administrators that are using digital assets, are using command line interfaces, APIs, and other capabilities to deploy applications, such as using, some people may have heard of things like Helm charts for how we deploy entire application sets. Now, when we're deploying these applications, not only are we able to do it, all of the application components at once, making it really easy to deploy. But we've got a single person that's mapping out how all of these work within a single digital asset that can be tested and then deployed into production when needed. So the expectation then with this CIO type talk is that, yes, we'll still have some server admins that'll do some things. We'll still have some network admins that still need to do some things in our environment. And there'll still be a requirement for some level of DBA work. But overall, we'll save some money overall in what we're doing, but we'll be spending an awful lot more on our cloud administrators, people who understand APIs, people who understand scripting, people that understand being able to build digital assets to deploy applications and capabilities in smart API delivered infrastructure and application sets. But this comes back as well to what we're talking about in the first session, the 7 R's of the application landscape of, are we going to retire, replace, relocate, replatform, rebuild, reuse, or re-architect our solutions? And this comes back to some of the things that we were talking about before. What do we do? Can we, if we've got existing virtual machines, can we convert them into microservices? In some cases, we can reasonably easily. Right? They're relatively small applications that are running a Linux operating system that we can convert directly into containers that allow us to create applications that can scale out really well. Right. Other systems may require complete re-architecting or something else. Now, when we're planning the cloud migration, we want to map out these, again, the 7 R's of what we're doing with the applications, understand how we're doing it, how we're operating the migration process, and having very clearly an application configuration register. We want to know all of the application sets that are in the data center and our environment overall. So I've been involved in multiple of these, and the application discovery process is one of the longest and most difficult parts of the whole migration piece, because understanding not only the applications that are in place in the data center, the systems that are in some ways unknown. So when I've migrated data centers, they've migrated all of the application sets that they've known, and then they've found that they've got multiple hardware security modules and other components that are really quite difficult to move, but they've now got a really short time frame to work out how to change those components. So pulling all of that information together and combining multiple tools together with physical floor walks for migrating data centers to another data center or to a cloud environment means that we have a clear understanding, but we're able to also very clearly map out where each of the applications are going. So if we've got 2 years before we need to exit a data center, we can move 50% of the applications to the public cloud. We can move 30% through to another smaller data center, and we can retire 10%, and 10% we can completely rebuild. Now, one of the things that people look at with refactoring or re-architecting applications is that it's really difficult, right? So if you've got a large line of business application which is custom, going through and rebuilding a large scale application is not an insignificant task. Often there'll be 50 or 100 developers that are working on it, as well as other ancillary staff, such as cloud administrators, project managers, other managers that are working in the mix as well. Right? So moving to new capability from a replatforming or rewriting capability, not insignificant. And that's why we see most applications end up getting rehomed, essentially putting on modern infrastructure, either new systems in a new data center or moving directly to the cloud. But if you do move to a model where you've got smart infrastructure, again, whether it's your own data center or if you move to one of the hyperscalers, moving to a model of having those cloud administrators rather than the individual people that look after each of the components. So in the current view of how we deploy new capability, we've got a hypervisor administrator that works on deploying virtual machines. We've got a server administrator, a storage admin, network admin. We've got some application specialists. We've got some other people that are involved. And 2 weeks, I think, is a pretty generous view for how long it often takes to deploy base capability for applications. It can often be a fair bit longer than that I'm sure many people have experienced for when they need to get some systems from an organization as well. But when we are deploying to on-demand infrastructure using code, we set out what it is that we need, what we expect everything to do with working with each other, and we can have it up and running really quickly. We don't need to do anything special. We create, again, our digital artifact, our digital asset for how it is that we're deploying the entire application set, and we click a few buttons. It's a single cloud administrator, which is then doing the deployment work rather than involving a bunch of other people. And the automation software within the cloud provider or the internal environment goes away and builds everything you require. Then looking at cloud native, just a question from Ray. I thought you might have mentioned Ansible. I haven't actually had a lot to do with Ansible. So it's been one of the places I worked with used it for deploying patches on their Linux systems. But yeah, I know it can do a lot more than that. Question from Stephen. The company I work for moved to a major enterprise application from own data center into the cloud. And aside from dollar saving, the end user experience latency downtime has been really positive. Yeah, so it's one of the things that I was reading through some research earlier today where they were talking about often there isn't necessarily a massive saving, but in some situations, right-sizing applications and being able to set the applications to be in the right application type set of the infrastructure that it's running on, etc., has meant that they get massive performance boosts. So they're not running on old legacy hardware that no one wanted to add new hardware to help support. All right, so going back to our Google Cloud Native principles. Again, when we're looking to deploy these, we want to design for automation, be smart with state, favor managed services, practice defense in depth, and always be architected. So these are really good ideals for how we deploy our applications in a cloud native sense. So cloud native, again, is where we are building things which are based upon code and scalable. Anything that doesn't require state doesn't have it, so that many of our systems are ephemeral. If we lose a component, it doesn't break the system, and we can easily recover by just running up another version of the same instance. So this is what the microservices architecture for Netflix looks like. Right? So what we see here is we've got 2 links from the client side. So from the client, we've got an enterprise load balancer. So this is just a load balancer coming into the Netflix network, which is hosted within AWS. We also have what it's calling here Open Connect. So the Open Connect services, any ISP can request hardware from Netflix, from Amazon Prime, from YouTube, and they'll host actual servers with content in their own data centers rather than having video requests go over the internet. So Netflix will give your own ISP for free a whole bunch of servers with a huge amount of storage locally within your own data center. And what that means is that when we are accessing those things, we are not traversing over to the US or to anywhere else to get access to any of our videos. And it saves the ISP a whole heap of money in the amount of traffic that they need to deal with. They just need to load the images once and the videos once, and then they're available from then on. From there, we've got servers that come through. We've got inbound requests going through microservices. You can see that we've got a Cassandra database up here. This is a NoSQL database that we were talking before. We've got a relational database, the different type of database that we were talking about last week for keeping track of all of the billing information, etc. We've got streaming information down here, so Kafka and Spark and other capabilities. So all of these components stitched together to build a cogent application and the way that our requests pass through the system overall. Now, one of the things which is pretty cool off this, I'll bring it over. If you have a look, just full screen this, don't mind the guy off to the side. I won't make sure he's not playing. This is a visualization of what the microservices within Netflix look like, seeing the flow of requests to the different microservices capabilities and points within the environment. So as you can see, they've got large numbers they've got their enterprise load balancer at the front, which then passes out to multiple web servers. And depending upon what it is that they require, they go through to different server capabilities from there. Now, one of the other things that you can see off the back of that, I'll just keep that playing. Don't mind what's on the screen or anything. But as I was mentioning before, your ISP has a server that's sitting within its own data center. And if we have a look through here, this little add-in for Chrome gives me a view of all of the different components, all of the different websites that are being accessed right now by the YouTube website. So I can see these are all of the different areas that it's pulling information from. And so we can see a whole bunch of ad information, but then we've got these Google video sites. So these would be the ones where it's actually pulling the video itself from. And so if we do reverse search on those, I think we'll probably find that they're in Australia. All right. But that brings us to the end of the course. And I've got one question waiting here. So how long will it be available for? So so that's just from Brad. Is that the?
I believe that's about the exam and the close dates. There are no close dates for the exam, so it'll just be on the learn.itmasters.edu.au page. There aren't any close dates for the exam. The close dates that there are for this short course apply only to the AWS lab environment,
yes,
which is in July. And yes, the recording will be available. All recordings and all course materials will be available at learn.itmasters.edu.au forever, basically. I mean, for the foreseeable future, and at the very least. Would you like to just finish up anything else with your presentation, Tim, and then I'll take people through a couple of details about the exam?
No, that's I'm all done. Thanks, Jen.
Brilliant. Well, thank you very much, Tim. round of applause, I suppose, everybody in their individual homes for Tim for presenting such a fantastic short course series over the last 4 weeks. It was really fantastic. If you absolutely can't get enough of learning about cloud solutions with Tim, he does take the subject, he's the instructor for the subject Architecting Cloud Solutions that is run as part of a variety of courses for IT Masters and Charles Sturt University in the courses for cloud computing and virtualization, cybersecurity, and networking and systems administration. So that's where you can find a little bit more from Tim if you are simply desperate to learn more about this fantastic topic. I would highly recommend it. So on the exam will be up in a few days. So it should be up before 4 p.m. or by 4 p.m. this Thursday, which is Australian Eastern Daylight Time. And then the results will be available via the certificate link on the course page at 4 p.m. on April the 7th. The exam details are that it is a 40 multiple choice question exam. You have 1 hour duration to complete those 40 questions in, and it is an open book exam, so it won't be proctored in any way. The AWS environment, if people are still not able to access that, have a look in all of your different email folders to see if it may have been sent to spam or promotions, etc. If you haven't yet received that, then you can get in touch with Short Courses at itmasters.edu.au. I saw another question which was related to, would we get a notification when the exam is up? No, there won't be any notifications. It will be up at 4 p.m. And again, yes, you are correct, Franklin. Hit the refresh button if the exam doesn't show up until it does. You can take the exam at any time. So it is not an exam that runs from 4 p.m. till 5 p.m. Australian Eastern Daylight Time. It is available from 4 p.m. Australian Eastern Daylight Time until indefinitely. So you can take the exam whenever is convenient for you and works for you. And the exam, is it a one-shot only exam? That is a great question. I can tell you that the pass mark is 50%, and you are allowed 1 attempt only. Yes, so 1 attempt, 1 hour, open book, and 50% pass mark. And you can take that whenever you like after 4 p.m. on Thursday. So once again, if you have any questions, check out the learn.itmasters.edu.au page to see if your question might be answered there. Alternatively, you can get in touch with Kit or Hannah via the email address shortcourses@itmasters.edu.au. If you're interested in further study with IT Masters, please feel free to fill in the eligibility form, which I think Kit is going to drop the link to in the chat at the moment. And overall, thank you so much for everybody's attendance and all of your fantastic questions. It's been really, really great level of engagement in all of these short courses. Thank you so much to everyone who's participated. We really, really appreciate it. And thank you so much to Kit and Hannah for doing all of the admin and tech support for it and for administering the short courses. And a big thank you to Tim as well for being a fantastic facilitator. Thanks very much.
Thanks very much. And just a final reminder that anyone who can, the links in the chat box to fill out the survey. That's really important for us to get just some information back on how this ran, whether you would like to see the same sort of thing in the future or what other types of short courses you'd appreciate.
Brilliant. Thank you so much, Tim. You filled in my last little bit there. The link is in the chat, just been dropped by Kit. So yeah, final thank you to everybody. We really, really appreciate your attendance and your participation. It's fantastic. please return for more short courses in the future if you are interested. Thank you very much. And again, good morning, good afternoon, good evening, or good night, depending on where in the world you are. Thanks very much. Bye, everyone.
Thanks, Jack.